Hello everyone, it's Nava here, and I want to share this video with you about something that is pretty recent and relevant, I think. Now, if you live in the United States, then you know that we are experiencing some pretty harsh cold weather, especially in the north and east coast part of the country. Now, with the drop in temperature, we usually see a rise in the influenza or flu virus during this time of the year. Since the flu is contagious, it can be spread via coughing, sneezing, or being in direct contact with something that has the virus on it. Now, there is very low humidity in the winter air, which is why you get very dry skin, chapped lips, scratchy throats, and nosebleeds more easily. Now, that's usually assumed that it's the cold air that causes people to get sick during the winter, but that's not actually the case. Studies have shown that the flu virus lives longer and spreads more rapidly in the dry air than in human air. And since temperature affects how much moisture the air can hold, we can see a correlation between low humidity and the increased spread of the flu virus during the winter months. Now, I don't want to get too in depth, as there's a lot of good information you can read on the flu virus, and I will definitely link some material in the description of this video for you. What I actually want to show you is an article that was published last month in a special issue of Optics and Photonics News. Now, this is a monthly magazine that provides coverage of many relevant developments in the field of optics, which is a subset of physics involving the behavior and properties of light and its interaction with matter. So as we can see here, researchers at the University of Louisville have developed a new way to detect different strands of the flu virus. And I wanted to highlight a couple of things from this article because I found it interesting. Early detection and diagnosis of different strands of the influenza virus, the main cause of the critical respiratory infections, are essential for treatment and for identifying pandemic outbreaks. This is true as many people become ill and unfortunately can result in death in many cases. Um, Here you can see they say immunoassay based detection. What this means is that it's a procedure for detecting and or measuring for specific proteins based on its properties, such as if it's an antigen or if it's an antibody. So our team has developed a strategy for immunosensor-based detection of viral pathogens that uses a sandwich bioassay on a single node electroactive integrated optical waveguide platform. Now that's a mouthful, but to summarize what like immunosensors are, they're compact devices that watch for the formation of antigen antibody complexes. Once these formations are detected, the information is then converted into an electrical signal that is processed and displayed to be monitored. Um, and we can see they mention the optical waveguide platform here. And what that is those are physical devices that guide visible light. An optical waveguide is a lot of times are used in components in integrated optical circuits. And these are pretty much similar to integrated circuits that uses electrons, except these use the electromagnetic waves, which are light. So this is a really good article, and I encourage everyone to check it out if you can. This is an application of physics that is manifesting itself in a way to help improve the human condition. So make sure you guys go out there to your local university and laboratory and thank a scientist and engineer for all the hard work that they're doing. And that's pretty much all I wanted to cover today. So if you found this video interesting, if you did, please leave a like and subscribe. Also, let me know what you thought in the comments below. Until then, I'm Nava Moore, and make sure you guys stay warm out there. Take care.